Hi everyone, welcome back to our YouTube channel. My name is Shiva Sharma, currently working as an applications engineer at Tech Savvy Engineers Private Limited. So today we would be discussing about the SolidWorks advanced mates. So in the SolidWorks, the mates are basically the geometric relationships that we apply between certain components. We have standard mates, advanced mates, and mechanical mates. The advanced mate we can say to be as the enhanced geometric relationship. In the standards mate, we have general relationships such as concentric, tangent, perpendicular, parallel, distance, and angle. However, what are advanced mates? The advanced mates are used to apply enhanced geometric relationship, often to do the job of multiple basic mates, but have more complicated effects. So there are certain types of mates in the advanced mates, like profile center, symmetric, width, path mate, and linear coupler. So we will be seeing them one by one, and we will be performing the practical to have a better idea of what actually are the advanced mates. So let us begin with the profile center. What is profile center? The profile center mate automatically center aligns the geometric profiles to each other and fully defines the components. Like we have to select the faces of the two bodies, and the geometric center will be getting the coincident. So let us see in the SolidWorks. This is my assembly window. Let us insert one component. Let's insert this plate. Make it fully defined, isometric. Let us insert one shaft. Okay, so as you can see, this shaft is floating in the environment, and I want to make the surface of this shaft and the geometric center, that is this circular cutout, to be to be concentric and to center align with the surface. Okay, so I would be going to the mates, then I would be moving on to the advanced mate. In the advanced mate, I would be selecting the profile center. After the profile center, you can see there is a mate selection tab. So what I have to do is I have to select the surface of this shaft and the surface of this bottom plate. As you can see, the shaft has automatically moved and get coincidence to the surface of the bottom plate, and also got concentric. So since it has got down, so I will do what is mate. I will change the mate alignment, so it will flip upside, and I will also do the lock rotation. As I perform the lock rotation, you can see in the status bar it has get fully defined. So I will click on OK, and you can see the shaft has automatically aligned to the geometric center of the plate. So this was the basic use of the profile center. Instead of doing coincident, then concentric, then lock rotation, we have a very good feature in the advancement, that is the profile center. Let's move on to the next mate. Which is the symmetric. Now symmetric we have studied in the 2D sketching also. Like it is just like making the component symmetric about one axis or a plane. So what is symmetric? Symmetric mate. Make two similar entities be symmetric about a planar face or a plane. It is similar to the symmetric feature used in the part designing. So let us check what exactly it does. I'll go to the SolidWorks assembly window. I'll make one component. Let's use this again. Okay, make it fully defined. And as we know that mates already work with respect to the fully defined component. So one component has to be fixed in the environment. So let us insert another part. Shaft. Now, first of all, what I will do is I will make this shaft and this cutout concentric and provide the lock rotation. Now, as you can see, I have fixed 1 degree of freedom, but it is moving in y-axis. So what I want is, I want like this surface and this surface to be symmetric about this plane. Now, if I use standard mates, then what I can do is I have to specify the distance from over here or from here to here. But in the symmetric mate, I can use this plane, and I have to make this surface and this surface symmetric. So let us do how it works. I will go to the mate. I will go to advanced mate. Then I will choose symmetric. Now in symmetric, you can see there are two planes, symmetry plane and the faces which we have to make symmetric with respect to the selected plane. So symmetry plane is this, and now I have to perform the selection, other selections, this surface and this surface. As I clicked that, you can see that the shaft has automatically moved down and has been symmetric with respect to the selected plane. I will click OK, and I will check to the front view. You can see that this was the plane which I have already selected, and these were the two surfaces. So the distance is equally separated. So instead of providing the distance, you can use a symmetric mate also. So this is also a very good feature. Let's move to the next command, the width command. The width command is extremely useful because the width command is also used, like it also makes ease of use during the motion study. So what is the width command? The width mate is extremely useful. It requires you to select two faces on the each of two separate parts and centers the two faces of the one part midway between the two faces of other. Means we have to select two width selection and the tab selections. Okay, so we would be understanding when we're performing the practical. So let's move to the SolidWorks window. Okay, assembly. Now I will insert some another component. Suppose now insert one plate also. Now over here you can see this component is fixed and this is floating in the environment. Now I want that to make this shaft to be center aligned inside this block, which is the part 5. So I want this to center align into this. Now, while using the standard mix, what we have to do, make this surface and this surface coincident, then this surface and this surface coincident. And also after putting this in, we have to give the inner depth. So I have to also specify the dimension so that it can go inside and fixed over there. Okay. But using the width command, we do not have to provide any of the dimensions or any of the standard relations. We have to just select the two faces. So let's go to the mate. Now go to the advanced mate and the width. Now width, you can see that it is asking for width selection and tab selection. Now in the width selection, you can select the two faces of the fully defined components between which the other component has to be selected. So I will select this face and this face. These are the width reference. Now in the tab selection, I will select the plate face between which I have to place the width command, assign the width command. So I will select this one and this face. Now this is the tab reference. I will click on OK. Now I have aligned along the x-axis. Now similarly, I will do it for the y-axis also. Now this plane and this plane is the width reference, and this surface and this surface. You can see as I have clicked, it is already moving in the to center align in the part 5. So you can see that I have, well, isometric view. It is only moving in z-axis. Now I have center aligned from the x-axis and the y-axis using the width command. Now similarly, we can do it for the z-axis also. Now I will select the mate. I'll go to the advanced mate and the width command. Now I will select this face and this face, and tab selection this face and this face. Now you can see in the status bar also, it has the component is fully defined now. Assembly is fully defined now. And we have center aligned the component into the part 5, which is this part, using the width mates. So width mates plays a very important role because in the complex geometry, when we would be using the standard mates, it will cause a lot of problem because we have to provide the coincident mate, then we have to specify the distance. So instead of using this, we can simply use the width mates. And as I told earlier, width mates is also very useful while we perform the motion analysis. So let's move to the next command. Our next command is path mate. The path mate is very common from the word also, like our component would be moving along a defined path. So what is a path mate? A path mate constrains a selected point on the component to a path. You can define the path by selecting one or more entities in the assembly. You can define pitch, yaw, and roll of the component as it travels along the path. We know that in the component there are 3 translational and 3 rotational. So pitch, row, and yaw are one of these. So in the figure, you can see that there is a gripper, arm gripper assembly, and the claw, in the claw, there would be a one vertex point that would be acting as a vertex of a component, which I have to move along the path. And as you can see in the sketch, and there is a spline made on which the vertex point would move. And actually, what is the vertex point? The vertex point is constrained to the component. So actually, the component would be moving along a path. So let us see how it works. I'll go to the SolidWorks. I'll insert one new component, right? Suppose this. Let us make it fully defined and isometric. Now I will insert another component. Now over here, I want that to this component, that is part 14. I want this component to move along this center line, like you can see that I have the sketch is in the show mode. So I want this vertex point of this component to be coincident on this, and I want this component to move along this line. So what I will do is I will go to the mate, then I will go to the advanced mate, then path mate. In the path mate, you can see it is asking for the mate selection, component vertex, and path selection. So in the component vertex, what is our component? Since this component is floating in the environment, so this is our main component which we have to move on the path. So I will select this vertex point. Now it is asking for the path selection. Now as you can see, the path it is in the path we have to use a selection manager because it contains of the multiple sketch. So we go to the selection manager and we will select the multiple curves on which our component has to be moved. We click on OK. As I clicked OK, you can see the component automatically moved to the starting point of the path. Okay. So over here, one thing we have to do more. The path constraint is free. Free means it will move freely along this path. Now pitch and yaw control. As I told, there are three rotational features. So pitch and yaw control, we have to give the follow path so that this component will move along this path. So I will click on OK. Now, as I click on OK, you can see this component is moving along the path, but its rotation is not fixed. So we can apply the standard mates. We will just select the two surfaces, make it parallel, and click on OK. Now I will move it in the environment. As you can see, the component is only moving on the path. Since I have only selected the vertex point and the sketch of the body on the path, and I will drag the component freely along the path, and you can see. So the main consideration during the path mate is that you need to assign one vertex point and one path, the sketch of the path. Okay. So this was the path mate. You can use the mouse and the cursor to freely move. Let's move on to the next mate. The next mate is our linear coupler. A linear coupler mate establish a relationship between the translation of one component and the translation of another component. When you create a linear coupler mate, you can set up the motion of each component with respect to the ground or with respect to a reference component. Okay. So let us see in the SOLIDWORKS. It would be more clear from there how to apply. Close this one. I'll go to the assembly. I'll insert another component for the linear coupler. Suppose I have selected this. Okay, fully define an isometric. Then I'll insert another component. This one. Firstly, I'll use the standard mates to fully define this component to make it concentric. I will perform the loop rotation also. So I've constrained this along the z-axis only. It will move along the z-axis only. I'll bring one more component. I will perform the same operations. I'll make it concentric and loop rotation. Okay. Now we'll move to the linear coupler. So I'll go to the mates, then advanced mate, then linear coupler. In the linear coupler, you have to perform only two selections. Here you can see 4 tabs, but you have to perform the simple 2 selections. You have to select the faces of the 2 components which you have to move along the shaft. So I'll select this face and this face. Now over here you can see it is asking me to perform the ratio. Like it is 1 mm is to 1 mm. If I move the component highlighted in the blue to the left towards 1 mm, then the component highlighted in purple will also move 1 mm to the left. However, if I perform the right 5 mm and I click on reverse, and then I will click on OK. I will manually add drag using the mouse. Now I have selected this component. I am moving it towards 1 mm towards the left, and you can see the right side of the component is moving 5 mm. I'm only dragging it to be 1 mm, and the right component is moving towards the 5 mm. So this is the basic work of the linear coupler. You can edit it also and make it to be in the same direction. Suppose I will write it to be 1 mm, and I will remove reverse and OK. Now you see I'm moving 1 mm towards left or right. My right component, like this part 16, it is also moving 1 mm is equally with equal distance with equal ratio 1:1. This was the feature of the path mate. It is very useful during the motion study and during the complex assemblies. when we require to show the motion analysis. So let us move to the next. Limit mates. These are the last mates. Limit mates are just similar to the distance mates and the angle mates which we have studied in the standard mates. The basic difference is it is saying limit. Like we have to limit the minimum distance and the maximum distance at the moment the component would be traveling. So what are limit mates? The limit mate allow the components to move within a range of values for distance and angle mates. You are specifying a starting angle or a starting distance and a maximum and a minimum value. For example, in this, you can see there is a connector linkage mechanism, and I want this shaft to move from the 10 mm to 50 mm. So I can specify the limit mates. And similar to this, there are the limit angles. So let us check in the SolidWorks what basically are the limit mates. I'll go to the SolidWorks. I'll open one new component. So let us select the first component which I have selected earlier. I'll make it fully defined and isometric. Let us drag and drop one another component. Okay. Now, first of all, I will use the standard mates to make this edge and this edge coincident, and this surface and this surface to be parallel. Now I will select the front view, and you can select only the angle. About the z-axis is not given, and I want that my angle should be specified from here to till some from till this angle. Okay, so I have to perform the limit angle. I have to specify some angle. Okay, so I will go to the mates, then I will go to the advanced mates, and over here you can see the option for the limit angle and the limit distance. So first of I will go with the limit angle. I will select the limit angle. I'll select the two faces, this face and this face. You can see it is automatically moving down towards 30 degrees. So I will specify over here 20 degrees. It has come more down. Now I have to specify the maximum angle. I will give to it as 150 degree. Now the minimum value is 20 degrees and maximum value is 150 degrees. I will click on OK. I will click on the front view. Now, as I am moving freely using the mouse, you can see that the component has got stopped at the 30 degrees and it will be moved till 150 degrees. We can check the evaluate measure. Yes, here you can see it has shown 150 degrees, and for the minimum distance also I will bring it down. Yes, it has stopped over here. Again I will check measure this edge and this edge. Here you can see it is 20 degrees. So I have specified over here at 20 degrees. Yes, 20 degrees to 150 degrees. Okay, so this was the limit angle. Like we can apply in the hinges. We see hinges in the offices, in the homes. So they are specified with an angle of the rotation from 20 degrees to 80 degrees or 70 degrees. So limit mates are used over there. Let us check the limit distance also. Let's just insert this component, make it fully defined. Okay, I will bring another component. First of all, I will use the standard mates. I'll make it to be parallel. Parallel. This surface and this surface is also parallel. Okay. Now I'll insert another component. I'll insert one shaft. I'll make this surface and this surface concentric and log rotation. And I'll make this face and this face to be coincident. Okay. Similarly, I will do for this plate, this and this to be and log rotation. Now I want my this part to be moving along the y-axis, but from certain distance to a certain amount of the maximum distance. So similar to the limit angles, we have to specify the two distances. So it is very easy. Go to the mates, go to the advanced mates. Then over here it is limit distance. So specify the two surfaces. Firstly, select the two surfaces. Now, since it is specified over 1 mm, suppose I will give 15 mm. So it has moved to the 15 mm to the minimum distance. Now I have to specify the maximum distance. Suppose maximum distance I want to give it as 70. I will click on OK. I'll go to the front view. Now you can see I'm dragging it too much upwards, but it is only stopping near the 70 degree, 70 distance, 70 mm distance. So this was the limit distance. So these were the certain type of mates Like in the advancement, we studied about the profile center, symmetric, width mate, path mate, linear coupler, and the limit distance and the limit angles. These are very useful because they are time saving, and they also help during the motion analysis, which I have already discussed earlier. So this was all about the mates. So if you have any queries regarding today's topic, you can definitely reach us out. And you can also reach us out to our hotline number 1800 889 2245, or mail us at support@techsavvy.co.in. Please like us on Facebook, connect, subscribe to our YouTube channel for more updates and more tips and tricks, and follow us on to our Twitter handle. Thank you so much and happy learning.